Welcome back to the workshop for our last video in proof methods. This last proof method isn't actually a proof method, it's a disproof method. So when we're disproving things, it's really nice. We don't have to be so formal. We just have to say, hey, this isn't right, this is wrong. So what that looks like is we can give what's called a counterexample. So if I want to say that something is true, but I can give an example where that thing is not true, then all I have to do is give an example where it's not true. That's it. That's a counterexample. So let's take a look at our notes. So when we are disproving something, again, we don't have the formal structure. So we can just say, all right, if I want to disprove something, all I need to do is say, hey, notice this. All right, so again, it's less formal. No indication of beginning of disproof, end of disproof. Nothing like that. And here in a disproof, when we disprove something, a specific example is perfect. We want to give an example where the thing is not true. So let's consider three sets A, B, and C. So it just sets. If A union B is equal to A union C, then B is equal to C. Is this implication true? It is not, right? There are many instances in which it is true. Notice it is true for let's see, if we were to let A be equal to 1, 2, 3, and if we were to let B be equal to, let's see here, 5, 6, and if we let C be equal to 5, 6, then A union B is equal to, let's see here, 1, 2, 3, 5, 6. Which is the same thing as A union C, which is, but yeah, it's the same thing. And B is equal to C. Hey, cool, right? So we just proved that it is true. No, we did not, right? We just gave an example of three sets A, B, and C where this is true. That's all that we did. Okay, and this is exactly why a example, if we just give an example when we're trying to prove something, it's not a proof at all, because you can give examples where something is true in a specific situation, but it's not true in general. And a proof is an argument, a justification, a demonstration that something is always going to be true. And this is exactly why we don't accept particular examples, because this is an example where that is true. However, in general, this thing is not true. How do I know that it's not true in general? Well, what I can do is I can notice for A equal to, let's have it be 1, 2, 3, 4, 5. For B equal to, let's see here, let's let B 1, 2, 3, and let's let C be equal to 4, 5. Then A union B is equal to A union C. In both cases, it's 1, 2, 3, 4, 5. Okay, we have that the union is the same. So we have the premise of the implication satisfied. The premise is true here. But we want to show that the conclusion is false. So yes, the premise is true, but B is certainly not equal to C in this case. B and C do not have anything in common at all. Therefore, the implication is false. And that's it, right? I didn't need to say, hey, I'm disproving something. Hey, I'm done disproving something. I just said, hey, notice, we've got this situation. The premise is satisfied, but the conclusion is not. Therefore, therefore the implication is false, right? Because that is the only scenario in which the implication is false, when the premise is true, but the conclusion is false. That's the only way. Okay, so we just have to give an example of that in order for us to conclude that in general, this implication is false. All right. And that's it, right? That's all that a counterexample is, disproving something, demonstrating that something isn't true. All right, that's all for now. That's the end of this section. Yay! Okay, if I have some time, I'll post some more examples. If you have some questions, that would be fantastic. I'll see you guys soon back here in the workshop.